Hi all. In this video we will be going over the intro to waves. The learning goals and objectives for this section is to know and recognize the wave equation, both general solutions and two specific solutions. Know that there is a relationship between the velocity of a wave and its frequency and wavelength. Also know other common wave velocity relations. Third is to understand what it means to oscillate in both space and time. So for starters, the wave equation is first going to write it down, then we're going to explain it. So, as has much been the theme in Physics 170, 171, we have a differential equation that governs the physics of the situation under investigation, and we don't actually expect you to solve it. What we expect you to do is, when we guess a solution, for you to put it into this differential equation and show that it does end up equaling 0, thereby proving that it is a solution. Guessing is a perfectly acceptable way to solve a differential equation. So what y is y is the amplitude of a wave as it travels through both a linear dimension, so a spatial dimension, x, and a temporal dimension, time. So as I said, you use this equation to verify that your guessed solution is in fact a solution. And as you saw in notes, some generalized solutions are f of x minus vt. This is a forward traveling wave. So f for forward, and it's x minus vt. So as it moves forward in time, this minus vt keeps moving it over. So the way I like to think about this is, say we had a function that is g of x equal to x squared, and then if we had g of x minus 3, then that would be equal to this. So moving the parabola over, so the 0 is now at 3. So that's what the minus vt for, and we also can have a backward traveling wave, so it's going to have a plus vt, backward. So this is the wave equation that you use to verify that something is a solution. So what you do is you get an f or b, and you do the differential, so you take the derivative twice with respect to position, the derivative twice with respect to time, you multiply by 1 over the velocity squared, and if it equals 0, it's a solution. So at this point, you probably want to know what f of x minus vt is, rather than it being some just abstraction that now it's saying, oh, there is a solution. You actually want to know what it looks like. You want to have some putty to play with. So one thing that we have written commonly is x minus vt plus v, or a cosine kx minus omega t plus v. So we need two free parameters, because it's a second order differential equation. That's what the phi and the amplitude a are for. And if you also notice, something special we did was we factored in this k, and what we did is we defined that k times v equals omega. Or you could say that V equals omega over K. So omega has units of 2 pi radians, or let's go with radians. So omega has units of radians per second. How do I